Okay. Okay, hello everyone. Can you please put the video on if you are connected and you can do it? Hello, can you guys see me? Okay, can you please put the video on if you can?
Yes.
Thank you. It's nice to see your faces at least once. Okay. So, oh, hi. Hi, Simon.
How are you?
Hello, Rachel. I'm fine. How about you?
It's been a while.
It's been a while. Welcome back. Okay. Hello, Rachel. And those are the students I know.
Hello.
Hi, Emily. I don't know you. Welcome. Hi, Tim. Also, I don't know you. Right? Do I? No. Okay. Hi, Mike. I know Michael.
Hello.
And Chris, can you join us? Hi, Chris. I know Chris. Welcome here. Some I know. Now, who else? Nick Solis, I don't know you, I think. Can you show us your face or you can't? Nick? Nick Solis? Okay. Gina, hi, Gina. Oh, hi, Nick. Hi, it's nice to see your faces. This is the only class where I can see people's faces. The other classes, I have like 50 students. Forget it. This is hopeless. Hi, Gina. Gina, are you in? Are you there? Okay. Adam, would you like to share with us your video? Adam, can you hear me? Adam Hume, can you hear me? Okay, Gina, hello. Okay, so you can hear me very well. And anybody else? There should be somebody missing. I don't know who. 1, 2, 3, 4, 5, 6, 7, 8. Now it's 9 of you. I have no. You have no webcam. Oh. Okay. All right, Gina, you don't have any webcam either? Okay. All right, so welcome to our class. It's discrete math. Of course, some of you know my name. My name is Norma Elias. And I will first go through the syllabus with you. And we talk a little bit about the course and then we get started. Okay, so for the syllabus, I will try to share the screen so we can go over it together. Okay. Share screen, here it is. All right. Okay. So let's go back. Now, of course, my office doesn't exist. It's virtual, so ignore that. My phone number is virtual, doesn't exist, also ignore that. And my email exists. Okay, that's my email, and you guys can email me. I mean, you guys feel comfortable to email me all the time. That's basically the best way for you to communicate with me. My office hours, which are virtual, as you guys know, 11 to 12, Tuesdays, Wednesday, and 3:30 to 4:30, Monday, Wednesday. And they will be conducted on Zoom, and you will have this. You have the Zoom invite already on Brightspace. So on Brightspace, you have the Zoom invite for the office hours. You just click and you're there. The book we are using, we're not buying any book. There is a book online that I think it's decent. So that's the book I will be using. Some of you probably, did any of you try to download the book or look at it? Anyway, so this is the book. You guys go to the website and it's very easy, and that's the book I will be using. So I may assign homework from the book, or I will do my own homework, but I will kind of rely on this book. Now, prerequisite for the course, I hope all of you have those prerequisites. You need in undergraduate level Calculus 3, minimum grade of C, or you should have 265 in your algebra with a minimum grade of C. So it's either or, it's not both of them. Seems to me most of you have both of them by now. Now, what is the course? This course is really kind of collection of stuff, if you want. It's not like one topic that you will be talking about it the whole semester. It will be like a mixture. So we will do a little bit of sets, what a set is. We will do some basic logic. And so we will develop a little bit the ability to write simple proof. We will do proof by induction. And we will do a little bit relation on sets. We will do counting, so combination, permutation, and we will solve problem using counting. And if we have time, this is part 4, it really depends, it's time constrained. If we have time, we will do a little bit about graph theory, which is actually kind of interesting. So if we have time, I hope I can cover this part as well. So it's like different kind of topic. The main thing in this course is really to develop your logical thinking. That's really what I am after the most. Whether it's a proof, whether it's sets, whether it's combinatorics, the basic idea is we develop our logical thinking. Now, homework. In this course, there will be no quizzes. You guys will have homework only. And the homework will be, so I will give you a homework, and the homework will be due 1 week to 10 days after it's given to you. And really this depends on the difficulty of the homework. So if I think the homework is rather simple, I'll give you a week. If the homework is actually kind of complicated, I will probably give you a little bit more time. The due date will be very clearly stated when the homework is assigned. So if I give you homework, I tell you exactly when I want it. And the homework will be handwritten, and you will have to learn how to basically also upload the document for me. The assignment will be graded and will be returned to you, and a solution will be then posted on Brightspace. And here I write that I encourage you to work together, of course, virtually, but the work you turn in must be your own. So if I see any cheating or you guys are copying from one another, I usually put a 0 on both copies, the one who cheated and the one that got cheated from. So be careful. So you can work together, but the work has to be absolutely your own. And the homework will be based on what we do in class, but the only way you're going to learn the material is really basically to sit down and actually do homework. I mean, there is no 2 ways of learning. There is one way. This one way is do the homework. And I'm quite available in my office hour to answer your questions. If you can't make it during my office hours, you can email me. We can set, a Zoom meeting together. So I strongly encourage you to get in touch with me if you have troubles, or, to get in touch with each other, but you have to do the homework. That's really what the whole course is about. Now the exams, I'm giving you only 1 midterm and 1 final. So it's not a lot of exams. So you will have, I have a date here, exam 1, October 21, and the final is during the final exam week. I hope we will be able to actually use this date. If something comes up, we can change. But for now, that's really my idea. Now the course is As you realize, I'm putting weight on the homework because I believe they are important. Okay, so I'm putting 50% on the homework, 20 on your midterm, and 30% on your final exam. So I really want this course to be about you guys doing homework, doing your work, come to, ask questions. That's really what I really would like you to get out of the course. Now, the last day to drop is November 13. I hope nobody will have to do that, but I have to write this on my syllabus. Grading scale is the basic grading scale. So nothing really different. 93 to 100 is an A, 90 to 92 is an A minus, and so on and so forth. And office hours. Okay, I strongly encourage you to use my office hours for help. If you cannot make it during my office hours, please talk to me and we can arrange a time to meet. And feel free to tell me if you're having trouble. Catching up can be very difficult once you get behind. So please let me know, I think, as soon as you think that you have a problem. Okay, attendance, I would like you to attend because we will be working in class. So, I'll give you a little problem, you guys work on it, and then we correct it. So your attendance is very important for you and for me as well, because it's an online course after all. Your contribution is as valuable as mine. So if you guys gonna sit there and just don't say anything, it's hard for me to talk to a computer screen. I mean, there is a limit to how much we can do that. So it's your contribution, your questions, your interest that will really help us in the course to be successful. And then on Brightspace, you guys will find the course syllabus, the homework assignments, solution to the homework, the grade for everything. So Brightspace is actually the way I will communicate with you. So if I have a homework, I'll put it on Brightspace. If I have the grade, will be put on Brightspace. The solution will be put on Brightspace, and so on and so forth. And somehow I ended up putting two things twice, forget about it. And then the Zoom etiquette, I hope I don't have to deal with that issue with you. Definitely I will not have to. So you have to act properly on Zoom. And this is a requirement that we have to put. So Zoom etiquette, COVID-19 preparedness, and every student who have no disability, please you guys talk to me and you will, I will accommodate you. And the rest are stuff that we have to put on on the syllabus. Okay. What else? Okay. Right before I start the lectures, basically ask me questions. Any questions about the course? Anyone? Okay. During the lecture, we'll be using chat. Already you guys are using it. So like if I ask you questions, basically feel comfortable to answer. And if you don't want to answer, you put it on chat. Okay. What matters is that I actually respect each other. If somebody is talking, try not to interrupt. That's really very important. And good luck. Okay. So right now I have to switch. Probably you won't see my face anymore. I'm back to the pencil and paper, which is gonna use as my chalkboard, and we start. Any questions? Okay, let's go. So now back to, okay. And I will pin myself down and I fix my paper. Okay. Now, please feel free to tell me we don't see. Feel free to tell me that it's not clear, and I will adjust it the best I can. All right, because that's really what we're gonna be working with. Like there's a piece of paper and this document camera. That's how the course will be handled. All right, so the first thing we're gonna be doing is basically chapter 2 in the book that I told you, and it is Introduction to Set. So that we call it is a language of set. So what is a set? So sets usually are used to group objects together. So suppose I am thinking about like all the even numbers. I'm not thinking about all possible numbers. I'm thinking only about the even numbers. So I would like to group them together. So I talk about the set of even numbers. If I'm thinking only about the student in my 348 class, okay, this collection of things, which are the student in my 348 class, I form a set. And I said, okay, let's consider the set that consists of all my students. So what is a set? A set is a collection of distinct objects. That's what a set is. Those objects are called the elements of the set. And the letters A, B, C will be used to denote a set. So what is a set for me, or for all of us? The set is actually a collection of objects. So I can think of a set as a container if you want. And inside this container, we have objects, distinct objects. What those objects are, usually those objects are connected to each other in some way or another. For example, suppose I'm thinking about all the integers between 1 and 4. It means I'm thinking at the following set that consists 1, 2, 3, 4. So you think of a set as a container, basically, that have distinct objects. Now, if A is, the objects themselves have a name and they are called element of the set. So I can talk about set A, which is here, I basically describe it to be the collection of the integers 1, 2, 3, 4. That's my collection. And if an object is an element of it, it means if an object is one of those, so suppose if A is element of it, okay, we use the following notation to describe this. We say A to that, which means that A is one of the objects in the set A. So in this scenario, 1 is one of the object. 2 is one of the object. If an element is not one of those, so if A is not element of big A, then we write A not element of A. Okay, so the element of A are basically those objects 1, 2, 3, 4. So in this scenario, 5 is not an element of A. However, 1 is an element of A. So a set is actually nothing really, not a lot. It's just a collection of objects. But it's a crucial thing because in every subject, a lot of time when we're talking about a set. We don't talk about things in general. We talk about something particular. And this particular, we will call it a set. Now, how do we represent a set? So how are we going to write a set? One way I will give you a set is basically by listing all the elements of the set. So how do we write a set? We list the element, all the elements. Okay, so how is a set given to you? One way is called, we list the element, and this will be called the roster method. But how do we list the element? Suppose I'm talking about the set that contains the element 1, 2, 3, 4. How I'm going to tell you that I'm thinking of 1, 2, 3, 4 as a collection of things? The way we write a set is that we put braces, 1, 2, 3, 4, and braces. Without braces, this is not a set, because without the braces, I'm only thinking about those as a bunch of numbers. The minute I'm thinking, put the braces, now this is a collection of things. So one way we can write is by list the element. So A equal 1, 2, 3, 4, that's what we call the rosters method. Now, the elements, those don't have to be numbers. Those elements could be anything. So I can create another set where the element, for example, could be 2 by 2 matrices. So 1, 0, 0, 1. And another element, 2, 0, 0, 2. A third element, 3, 0, 0, 3. Do you see the pattern that I am building? You guys see the pattern? Anybody? What's the pattern I'm building? What do you think the fourth element would be?
Your
Go ahead.
4004.
Okay, so basically, if you guys remember, those are the multiples of the identity. That's 4 times the identity, 3 times the identity, 2 times the identity, and so on and so forth. So this is, I'm building a pattern. So I can say dot, 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 and I can say dot, dot, dot. And here I can say the general term is that I say it's 100, 0, 0, 100, and so on. So this is a set. What are the elements of the set? They are matrices, 2 by 2 matrices. What type of matrices they are? They are the matrices which are 0 of the diagonal, and they are the same term on the diagonal. So that's really that's my set. It's a very specific collection of stuff. So based on this, suppose I take the following matrix, 0, 1, 2. This is not an element of B, because it doesn't really follow the pattern. Okay, so one way we will describe a set is by listing the element. What matters, as I repeat myself several times here, is the braces. Without the braces, this is not a set. Without the braces, is a bunch of numbers. They are not connected. I'm not looking at them as a whole. You have to put the braces, and now we're talking about a set. Now, what characterizes a set? What characterizes a set are its distinct elements. That's really what characterizes a set. So what do I mean by that? So I mean by that is the following. It means that the order in which I write the elements doesn't really matter for a set. If I write the same element 15 times, it's irrelevant. So what really characterize a set are all its distinct elements. So, and this is kind of promote or not, this is motivate the following definition. If I have two sets A and B, what does it mean to say that A and B are the same set? So if what characterizes the set are its distinct elements, so what does it mean to say that A and B are equal? Anybody would like to give it a try? Anybody would like to give me definition? Come on. So if you have two sets, and what does it mean to be equal? All right, I will not really write it down, but I'm going to give you examples and I'm going to ask you the questions. Are those equal sets? Okay, so let me give you the following set. Let A be the following. 1, 2, 3, 4. Let B be the following set. 3, 2, 1, 4. Let C be the following set. 1, 1, 2, 3, 3, 4. Am I talking about the same set? Yes or no? A and B, are those the same set?
Yes.
Yes.
Why? Because they have exactly the same element. 1 is in both, 2 is in both, 3 in both, 4 in both. So they have the exactly same distinct element. What about A and C?
Yes.
Are those the same set? And the answer is yes. Why they have the same set? Repeating twice does not really matter. What are the distinct elements of C? 1, 2, 3, 4. They both have the exact same element. All right, so A equal to B, if you have two sets A, the A is equal to B if the sets A and B have exactly the same element. Distinct element, of course. So for example, if I ask you how many elements does C have? How many elements does C have? 1, 2, 3, 4. 4 elements. How many elements? Of course, A have 4 elements, B have 4 elements. It's to C, which has exactly 4 elements. All right, so two sets are equal if they have exactly the same element. So let me ask you two true or false question, two simple ones. Right. Suppose I take the following set. Okay. Braces, I'm going to talk about set. I don't need absolute value. Sorry. Are those the same set? Yes or no? That's the question. Are those, is this equality true or false? Who say yes, who say no? I need voices. Unmute yourself and answer.
I think it's the same because when you take the absolute value of -2 and 2, you still get 2.
Right, they are absolutely the same. I'm repeating 2 and 2 twice. End of the problem. Are they equal? Yes. They are. We're talking about the same element because absolute value of -2 is 2. Absolute value of 2 is 2. So this set is actually the 2, 2. So we're talking about exactly the same set. Okay, let me take another example. Okay. Suppose I take this set. 1 and 2. This one. And my question is the following. Is this equal to that? Again, true or false?
False.
False, because
The first set has one of its distinct elements is also a set.
right. So how many elements does this have?
2.
How many elements this have?
What?
How can we visualize this? Let's visualize this a little bit. Okay, if I imagine a set as a container, what this is? What does this container have? It has 1. And what else it has? Another set. It means within it, there is another container that have 1. So that's how you can really imagine, very different. However, this one is a container that have 1 object, which is 1. Very different from one another. Right. Now so one way we're going to describe the set are basically by listing its element like we did. Now, there is another way we describe a set. But before we do that, let me remind you some basic sets that we will refer to continuously in this course, and every other math class you guys will, will take. So very, very specific set. I will introduce them and then I will use them after that. Okay, special set. First, N. The set N. The set N is the set of all integers, positive integers together with 0, 2, 3, 4, etc. So this is the set of natural numbers. So whenever I say N, I'm talking the set of natural numbers. So whenever I'm talking about N, that's exactly what I'm talking about. Another set that's very important for us is Z. Z is the set of all integers, positive or negative. So Z is 0, 1, 2, 3, etc. All the integers, positive, negative, -1, -2, -3, and so on. So that's the set of all integers, positive as well as negative. Okay. Now, what other sets are important for us? Sometimes we talk about Z, and I put a plus in here. Z plus is all the positive integers. So there is no 0 in here. Z plus would be the 1, the 2, the 3, the 4, the 5, etc. All the positive integers. And then for the same token, I can talk also about like a Z minus, which by now I think you understand, you can imagine what it means. So dot, 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 -3, -2, -1, all the negative integers. Another set, two other sets actually are important for us. Q, which is called the set of rational numbers. So what is Q? Q is all real number. I'm going to describe this one in word, not between braces, because I did not introduce the notation I need for that. So for now, all real numbers of the form. So Q are all the real numbers of the form P divided by Q, where Q, P is an integer, Q is an integer, and of course, Q different from 0. Okay, and this is called the set of all, this is called the set of all rational numbers. Okay, so those are basic set. These are like the ABCs of set that we definitely always refer to them. So example of the elements of Q, for example, 2/3. This is in Q because that's the ratio of an integer over an integer. That's element of Q. Let us say another element of Q, 2. Is 2 an element of Q? Yes or not? Quickly. When I ask a question, I want a quick answers, okay? Is 2 an element of Q? What's the P? P is 2, the Q is 1. Okay, so these are the element of Q. Now, what's not an element of Q? Who can give me something not in Q? I want an element not in Q. Anybody?
2 divided 0.5.
2 divided by? I'm listening.
0.5?
25?
No. Pi.
Pi. Yeah. This is not in Q because pi is not an integer. It's actually an irrational number. And the last set we're interested in is R. R is everything. The set of all numbers. Then pi is definitely an element of R because pi is a number. It's a number, 3 point something. All right. So these are the set that I will be always referring to, and we should have them very well. So now let me go back to how is a set given to you. So as I said, first way a set is given to us is by listing its term. But sometimes a set has a lot of terms, and it's absolutely impossible to list the terms. So what's going to be another way of writing a set? So we're going to talk about another way to describe a set, which we'll be calling the following. So the set builder notation. Okay, so that's a different way of describing a set. What's the set builder notation? Set builder notation is the following. Instead of listing all the elements of the set, what we are going to do is talk about the property of the element. So instead of listing them, we'll talk about the property. So the way we're going to write it is like this. It's going to be the first part, I will tell you the domain. It means where those elements are. The second, we will talk about the property. So let me make myself very clear here. Let us say I tell you that A, B, the set of all n in Z, so this is the domain of my element, such that now the property, very simple, n is even. Okay, so instead of listing, I said all the element in Z such that n is even. The domain, and that's the property. So let us see what is A. Now we're going to list them, so make sure we understand that. So what is A? Everything even. All the n in Z. So 0 is even, 2, 4, 5. That's what it is. And -2, -3, and so on and so forth. So that's really my A. So instead of listing, I'm going to say all the n in Z such that n is even. Now, suppose I take the following. All the n in N such that n is even. Am I talking about the same set? Yes or no?
No.
Am I talking about the same set? My domain are all the n in N. So now I'm not taking all the n in Z, so my set would become 0, 2, 4, 6, 2, 4, 6, and so on. Okay, so one way, if you have a set, instead of listing, we would use what we call the set builder, the domain of the element, and then the property of this element. Now there is a variation on this. So we're going to talk a little bit about a small variation. So another variation that we will encounter, and we have to learn it, another variation of the set builder is the following. Instead of writing the domain first, then the property, the first piece will contain, I would say, the form of the expression. Form of the expression. What kind of form we're after? And the second part will contain basically the restriction on the variable in the form of the expression. So this part will be made clear in the example, some kind of the restriction on domain. So that's another variation. Let's see what I'm talking about. Suppose I want to talk about the even numbers. One way to talk about them, I tell you all the integers, that set n is even. Now, another way I can describe the set is by telling you the form of the expression. Now, if a number is even, what's the form of an even number? A typical even number, what kind of form does it have?
Do you mean 2 times n?
2 times something, right? So 2 is 2 times 1. 4, 2 times 2. 6, 2 times 3. 2 times 4, 2 times 5. So one way we can write this is first we can write the form of the expression. So I will say A is the set of everything of the form 2n. That's the form of the expression. Such that, where is this n now? So I'm introducing the variable, but I want to tell you where does this n is. Where this n, it depends on the problem. If I want all the even, positive and negative, where this n is in Z. Okay, so that's actually a variation of the first notation. So we can either use this one or this one. They mean exactly the same thing. So let us try now the odd numbers. Let's write the odd numbers using this form of the set builder notation, form of the expression and then the restriction. Okay. How can an odd number look like? Every odd number is an even plus 1. That's how odd numbers looks like. All right, so help me out quickly. How do you want me to write it? First, the form of the expression, then the restriction on your variable.
2n plus 1.
2n plus 1. No, but this is not enough. Unless you tell me where your n is, this is not a complete sentence. And could be a real number. Then I'm not, so I want the odd numbers. And I want let us say I want all the odd. If I want all of them, I want my n to be an element of C. So that's how we're going to write it. So I will practice a little bit. We're going to practice this notation a little bit because it's important. So I'm going to give you sets, and your job is to write them by listing the elements. So my question is, write by listing the elements. Okay. All right. So the first set, all the x in Z such that absolute value of 3x is strictly less than 7. So here I'm writing the domain. I want all the integers that satisfy the condition absolute 3x is less than 7. And my question is, I want you to list all the elements of this set. All right? Whoever is ready, let me know. Anybody ready? Okay, so I want all the integers.
So -2, -1, 0, 1, 2.
Is she correct? Let's see. There are several ways of looking at it. You want the absolute value of 3x, so absolute value of 3x. You want this less than 7. It means you want 3 times the absolute x to be less than 7. It means you want x in absolute value. That's one way you think about it, to be less than 7/3. One way to think about it. That's what you want your x. Okay, if you want the absolute value of x less than 7/3 and you want x to be an integer, what are the x's? Okay, 0 satisfies it. Now 7/3 is a little bit over 2 point something. So 0 satisfies it, 1 satisfies it, 2 satisfies it. Since I want the absolute value, I need -1 and -2. And this set is exactly this one. Let's take up another example. Suppose I have the following set. Watch how I'm gonna write it. 3x such that x is an integer and x less than 4. How do I read this thing? How do I read it? It means I'm interested in all the element that has the 4 3 times x. This is the 4 I want. But this variable, what does it satisfy? I want my variable to be an integer. I want it, an absolute value, to be less than 4. So everything of the form 3x, but this x have this type of restriction. So let's list the element of this so we can fully understand the notation. Okay. Everyone should write in front of you. You have to write the answer. Think about it. I don't see you, but you guys have to be, you have to think with me. So I'm thinking about everything of the form 3x. This is the form, the expression, but this x satisfies this condition. Anybody ready before we discuss it? Nick Solis, can you do it? Can you share with us your answers? So let me ask one question. Is 1 an element of this set?
No.
Is 1 an element? I'm listening to no. Why no? Can I write 1?
Because it's like 3 times.
Exactly, but can I write 1 as 3 times an integer? No way. 3 times an integer, so 1 is not. Absolutely correct. So what are the terms here? 3x? I don't want to give the answer. I want one of you to talk.
Would it be -9, -6, -3, 0, 3, 6, 9?
I think you are right. Justify. You're absolutely correct. Tell me, what did you look for?
Because it's x, or the absolute value of x has to be less than 4.
Right?
So I know it would be -3, -1,
You're
to
absolutely
3.
right.
And I just multiplied by 3.
Absolute x less than 4, it means x could be 0, plus or minus 1, plus or minus 2, plus or minus 3. That's the x. But what I'm interested in is everything of the form 3x. So it's 0, plus or minus 3, plus or minus 6, plus or minus 9. That's how we read the statement. Okay, let me give you one more. And then I'm going to go backward. Suppose I take 3x plus 1. That's the form of my expression. But now I'm going to be easier. X in n. I want you to list. What am I talking about? We won't be able to list all of them, but at least we're going to list really actually the beginning. So this is, I'm giving you the form of the expression. And then I'm giving you basically the condition on my variable. Yeah, I'll give you 30 seconds to do that.
So a set starting with 1.
1. Where did you get 1
Yeah.
from? You are correct. But I asked you, where did you get it from?
Well, if x is 0, then it's
X is 0, we get in 1. Absolutely. And then?
Yeah. Well, 1, then 4, then 7,
Then
whatever.
Then whatever. Okay, that will be the set we're talking about. So 1, 4, 7, 10. Then this should be what after 10?
13.
13. Okay, that's what the set we're talking about. So instead of talking about, so please mute, I will talk about everything. Basically, these are all the terms. When you divide them by 3, you get a remainder of 1. That's really what I am talking about. So I will write them as 3x plus 1. All right. Now I'm going to go backward. I'm going to give you the list. I want you to write it in either the first format, domain, property, whichever you want, or in the format, the form of the expression and condition on the variable. You have the freedom to choose. I will not force any of them. So the question now, write in set builder notation. All right. So these are my questions. I start with the easy one. So I'm going to write plus or minus 1, plus or minus 3, plus. So usually I give you a pattern. And after that, you have to look at the pattern and tell me, how can you write this in a more compact way? Okay, so you set builder, as I said, you have the freedom to pick domain, property, or the shape of the form of the expression, and then condition. Okay, I give you also like a minute at most to do it for me.
So this is
Okay, are you right? And sometimes you guys can probably put your paper on the screen and we pin it down if you cannot tell me, exactly. All right, who would like to give me a, a suggestion? Who have one?
oh wait, no, that's wrong.
So of course I have a very clear pattern, right? Who's ready? Rachel, any idea?
I agreed with 2n plus 1 and then n being an element of z.
So you like this form?
I do.
Okay, and in Z.
I think that's wrong though. I think I was wrong when I said that. Because the growth of the positive and negative part are at the same rate, and if n was negative plus 1, you should expect it to be the integer to be 1 lower, if that makes any sense, or 1 element closer to 0, if that makes any sense. So like,
I'm trying to follow.
so if I have 2n plus 1 and I have 0, right?
Yes.
Then I'm always going to get positive 1. I'll never get negative. Oh, wait.
Oh, n is in Z.
Yeah.
Okay, so how can you get minus 1? 2 times what plus 1 will give me minus 1.
So you'd get, it would be negative 1, right?
Right.
But I guess you would still skip the even numbers.
Absolutely. There is no way I can get an even number. Why? Because 2n is what? 2n is even. So when I'm going to add 1 to it, of course I'm going to add odd numbers.
I'll shift it off the even numbers by the plus 1. All the even numbers will be, yeah.
Okay.
I was just thinking that you would get 1 at 0 and negative 1 at
No. At 0 you
negative
get
1.
At negative 1 you get negative 1.
Yeah.
Because I'm allowing n to be in 0. Good. Let me give you another one. And you guys have the freedom to pick which set builder notation you want. 2, 4, 8, 16. My pattern is very simple. Okay.
Do the natural numbers include 0? No.
What? Yes, 0 is a natural number. All right, so I have one suggestion from, okay, one student wrote 2 to the n, because of course I realized the pattern.
Yeah.
Not hidden. That's 4 is 2 squared, 2 cubed, 2 to the power 4. So I'm not giving you a really hard pattern, and that's 2 to the power 1.
East yard on the southeast, on Indianapolis Boulevard, although it's open.
Please, if somebody.
That doesn't work though, because at 2 to the 0. Right?
Okay, so n is where? I introduced this set. What did
Would
I
it be
do?
through the z plus?
Exactly, z plus. Because z plus does not contain 0. All right, so we can fix it to have it z plus. Very good. All right, now, does anybody want to write it in a different way? Okay. Now let me.
I have it written as. Oh,
I'm listening.
I had it written as 2 to the n plus 1, such that n is in the natural numbers.
Is he correct? Is he correct? If n is 0, he'll pick up the 2. If n is 1, 2 squared, absolutely correct. All right? Now, 2 more examples along those lines. This one should be easy. Not easy because there is a reason why it's easy, because I just did it. Okay. Again, you have to watch the pattern and tell me how you want me to write this is using set builder notation.
So this is 3n plus 1 in z.
Right, that's 3n plus 1. What is n this time though? Is it an integer or in z?
I said it was in z.
It has to be in z because I'm picking up the negative number. So when you have a list like this, usually you have a pattern and your job is really, figure out the pattern. Now, before I move on, I'm going to take this set a little bit. The best way to write this in set builder is the way you guys wrote it. That's the best way. There is no other, I will not even discuss that. But let me see, let us say somebody wrote this set in the following way. This is going to look a little bit complicated, but I think we should know also. Suppose I write this as all the n in z, such that n is equal 2 to the k, where k is an element of z plus. Is this a correct way of writing it? Am I correct in this way? So a little bit more complicated, but we have to be, actually we have to learn. So what I'm talking about, all the integers, but not any integers. So here I'm putting the domain and here the properties. Or the integer, where my integer have the following property. They are of the form 2 to the k, where k is in z. So
Yes, that's technically correct, but there's no reason to do it.
absolutely correct, but that's technically correct. That's technically correct, and I want you to be aware of it because you will see that written sometimes this way. This is the easiest way, but that's technically correct, and it's important for us to know it. Okay. Now, suppose I take the following set. All the x in z, such that x squared equal minus 1. Okay? What's this set? Most of you probably know it, but I have to introduce it. List the element.
Is that x squared or x to the z?
X squared. Thank you.
Okay.
Right? Anyone?
Would it be the empty set
Definitely it's the empty set.
or?
Or
Okay.
there is no or. Why is the empty set? My x is where? It's an integer. So I'm being very clear about the domain. That satisfy x squared equal minus 1. Now, can you think of an integer that satisfy x squared equal minus 1? Absolutely not. So how are we going to write the empty set? So this is definitely the empty set. So how do we write the empty set? One way, which is the way that's not used a lot, is open braces. There is nothing. Close spaces. That's one way you can write it. But the most common way of writing this, the empty set, is like a 0, like that. So that's an empty set. So what's the empty set? It's basically a set that has no element. Are there sets that have no element? Yeah, the set you're seeing right there is a set with no element. So the empty set is nothing more than the set that have no element. Okay, one more word is about the cardinality of a set, and then we move to subset. So cardinality. What's the cardinality of a set? Suppose A is a set, a finite set. Finite set means it's not infinite, means the number of elements is finite. Then the cardinality of A which we denote by cardinality of A. It's kind of confusing because like it's the same as the absolute value, but that's the cardinality. It's nothing more than the number of elements of A. As simple as that. Of A. So the cardinality of A is number of elements, distinct element. I have to make sure of that. Element of A. Okay, so it's definition that absolutely important, but we have to know it. So for example, very straightforward example. Suppose A is 1, 2, 3, 4, 5. The cardinality, do not confuse cardinality with absolute value. We talk about cardinality of a set and absolute value of a number. So we have to be very careful of that. So here, 5, that's the cardinality. Suppose A is the empty set, there's nothing in it, and the cardinality is 0 because there is nothing in it. So the cardinality is 0. Okay. Right. So these are sets that we'll be working with them. Basically, you guys, math major, will be working with set all the time. Now we're going to talk about a subset. Right. What's the idea of a subset? And this is section 2.3 in your book. What's the idea of a subset? So suppose you have a set, which is, is a container that has element 1, 2, 3, 4, 5, 6. So this is my set. I call it B. 3, 4, 5, 6. And within the set, I'm interested in particular object. So let us see, I'm interested in the even numbers within the set. Within it, I'm interested in the subcollection. Okay, so I'm interested in the set A, which is in here, only the even number. So I'm only interested in the even within the set B. So we are going to call A subset of B. So I have a set, but I'm interested in specific element within the set. So I can construct a new set, and this new set will be called a subset of B. So let us introduce subset more formally. So let A and B be two sets. We say that A is a subset of B if every element of A is an element of B. And we use the following notation. A subset of B to indicate, so A is this inclusion in B to indicate that A is a subset of B. It means every element in A, crucial, is also an element of B. But of course, B can have more elements, but everything in A is also an element of B. Now, what does it mean to say A is not a subset of B? So, a subset of B, it means every element here is in here. What does it mean that A not a subset of B? What does this mean? So it means it's not true it is a subset. But how can A fail to be a subset of B? What does this mean? Anybody has any input?
contains elements that are not in B.
Has element which is not in B. That's absolutely correct. But how are we going to write this mathematically? We write A with this symbol not in B to mean A is not a subset of B. What does this mean? It means there are elements in A, at least one, not more. At least one element of A that is not in B. Some element of A can be in B, but this means that at least some are not in B. Okay, so let us again work with a very, very simple example before we move on. So suppose I have A to B, oh sorry, B, let me start with B. Again, 1, 2, 3, 4, 5, let us say. Okay, so I'm gonna list 2 subsets of B. So list or give me 2 subsets of B. All right, we're gonna, all right. Who would like to give me the first subset? As you realize, I immediately put braces. And who can give me another subset? Okay. Let me pick. Gina, give me one subset. Gina, are you with me? Okay. Emily?
1, 3, and 5.
1, 3, and 5. She picked the odd. All right. Emily, give me another one.
2 and 4.
2 and 4. You can give me a lot of subsets. Now I want D, a set D such that D is not a subset of B. And I'm going to start with it. So I'm going to give you 1, 2, 3. Finish it. So D will not be a subset of B. Give me one more element. Rachel.
7.
7. I'm done. One element. And I am done. Okay. So it's one element, not every element, not element. So now let me give you 2 more examples, and then we keep talking. So example number 2, if you want, let A be the following. All the integers n, actually z plus, such that n divisible by 4. And then I'm going to take B, all the integers, such that n divisible by 2. And finally, C, I'm going to take it all the integers, and let us say divisible by 6. Okay, just bunch of that, and I'm asking you true or false. A subset of B, true or false. C is a subset of B, true or false. And B is a subset of A. Okay, so we start with the first one. Is A a subset of B? Let's understand A, understand B, and then ask ourselves, is A a subset of B? If yes, give me a justification. If not, you have to give me a specific element in A which is not in B. That's how you tell me not. Okay, the first one, true or false?
I think it's true.
You think it's true because what is A? Let's list so we can understand it. Divisible by 4.
4, 8,
4,
8.
8. So it's 4 times something.
Right.
Right? B. 2 times times something. Okay, so is A a subset of B? Means if an element could be written 4 times something, can I also write it as 2 times something? True or false?
True.
Okay, now eventually we will learn how to prove it. Now I just want to have a feeling for it. Is B is a subset of A? If yes, give me an idea. If not, you have to give me specific. So I'm working on this one. I'm skipping the second one, this. If not, you give me a specific element in here, in B, which is not in A, all right? What do you think, true or false?
False.
False, because?
Because 2's in B, but not in A.
Because 2, specific element. But 2 is not in A. So when you tell me it's not included, there is a reason. You have to give me something in here that's not in here. Okay, finally, C is a subset of B. C is a subset of B. Okay, what do you think? True or false? So C is everything divisible by 6. So 6.
It's true.
It's true. Okay, because if something is divisible by 6, so it's 6 times 1, 6 times 2, etc. So now we're not proving. Very soon you can prove this easily. So if it's 6 times something times an integer, 6 is 2 times 3. It means that's 2 times 3 times an integer. So if it's going to be divisible by 6, of course, because 6 is 2 times 3, it's going to be divisible by 2. So C inside B is absolutely a true statement. All right. The last few minutes, I'm going to again ask you the following questions. Again, idea of symbolism. We introduced 2 symbols today. This symbols and this one. Okay, very important symbols, crucial. What does this symbol mean? If I have this symbol, what should go here and what should go here, basically? Here is a set, and here, element of the set. Okay, that's when we use the symbol. Inclusion compares what? Compare a set to another set. So very, very different. Here, I'm talking about one set inside another one. Here, I'm talking an element inside a set. So I'll ask one question and then I will we stop because I have a linear algebra class right after you. So I have to leave some energy. Suppose this is my A, okay? And my question to you is the following. So my A is a set, it's like this container. It has a loose element 1, it has a loose element 2, and then within it there is a container that contains 1. So this is really my set A. I mean, okay. Now my question to you. For each term below, determine if it's an element of A. I'm going to give you stuff. Your answer should be element of A, subset of A, both, or neither. Okay, so I'm going to give you 2 examples only, and your answer should be that's an element, it's a subset, that's both or neither. Very good. So I'll start with a simple one. 1, I can put this in red. 1. Element, subset, both or neither. Quickly. Quickly. I don't like to pick, but you're gonna make me to.
Element.
Element. Why? It's one of those. So 1 is an element of A. All right. 2. What if I take element, subset, both, or neither?
Both.
Both? Do you agree with him? Both. Why? 1, how are you going to justify? This is an element of A. This is an element of A. So, sorry. So the subset, this is a subset of A. Okay, because 1 is an element, so this is a subset of A. Second, this one is also an element of A because it is one of them. So it's a subset of A and it's an element of A as well. So we have to really be careful with that. Okay, my last example is, so this is both. So suppose I take the following. Is it an element? Is it a subset? Justify. I have 1 minute. Is this an element? Question number 1.
No.
No, because it's not nowhere to be seen. There is nothing else to it. Element, I have to see them, to see it here. Is it this one? No. Is it this one? No. Is it this one? No. So definitely not element. Is it a subset?
Yes.
Because?
The element, well, one of the elements of A is the set one, so then the subset of...
Exactly, because what does it mean to be subset? Every element here should be in A. But this has one element, which is that one. That's the only element. Is this in A? Yeah, it's right there, staring at us. So this is inside of A because the element 1 is in A. Watch carefully. This is a subset because this is an element of A. Okay? All right, so that's it for today. For Wednesday, you'll not have a written homework for Wednesday, but sometimes tonight I will put some practice problem from the book. Okay, just practice them, not to hand in or anything, just practice them. And if you guys have any questions about them, you will ask me on Wednesday. All right, good luck for the semester and see you soon. See you on Wednesday. Bye-bye.